Hi, students. I left a long pause at the end of sensory memory. I was giving you a little bit of time to think about what we had just talked about in the previous sections. If you were paying attention, and maybe even if you weren't, some information got through, and you began to think about what I had just presented to you. If you did that, when you were thinking about the characteristics of sensory memory, or even the characteristics in general of this whole memory process, the place, and it makes it look like it sounds like one location in your brain, and it's not. But that structure, that whole part of the model is called short-term or working memory. We used to call it short-term, but now, because we know so much more about its capabilities, we consider it like a desktop, where you work, what you're thinking about right now. It's just like on your table or your desktop. What you're working on right now is there before you. It's the same thing that we're talking about now. What you are thinking about now is in your working memory. That's this part of the structure of memory, the information processing model. It's this part, working memory. Sometimes you'll see a separate part called short-term and then working memory. Just, you can consider that the whole thing is working memory. There's some processes involved, as you can see with these arrows going back and forth, and I'll come back and we can talk about those. But let me give you some of the major characteristics of short-term memory. I've written them out because I think it's important for you to both visually see them and hear me talk about them. It's a working memory. You could think of it like a computer scratch pad, or the file on your computer that's open where you're typing things in. How is information encoded? It is still probably encoded in the way that it was brought in through sensory memory. That means as icons or echoes, as images and sounds. You're going to give it meaning as you're working on it in memory, in working memory, but it probably comes in initially as icons or echoes. Again, it's limited duration. I'm going to come back to this. It's 20 seconds or less, generally. If you do not rehearse information, it's not going to last more than 20 seconds. And to keep that duration going, you have to rehearse this information. So I like to use the story of, on one side in my living room, on one side is the phone, on the other side the phone book. I'm going to order pizza. I walk over to the phone. I look up the phone number for the pizza place. And as I'm walking, I go over to the phone book to look it up. As I'm walking back to the phone, I'm saying it out loud to myself. 1-866, 233-3747, whatever the number is, as I walk back to the telephone. Now, if somebody says to me, like if my husband says, make mine anchovies, guess what? I've forgotten the phone number. It's pushed it off out of my memory. I have to go back and look up the phone number. So now you can see about the problem again with interference or interruptions is if we're thinking about something and somebody interrupts us, we've got to bring that information all the way back in and start over again. It has a duration capacity that can be increased if we do rehearsal, if we think about it as it's in memory. But if something happens to take our attention away, we've got to bring it back into memory again. It also has a limited size. It only holds a small amount of information, and it's the magic number 7 plus or minus 2. I think in the 50s, George Miller, no relation, did a very nice study in which he tried to determine the average size of working memory or short-term memory. And he came up with 7 bits of information plus or minus 2. Because you're going to say, what's a bit? Well, this is, again, when we get back to the computer foundation, the early models of how do we think about memory. It's a unit. I don't know. I don't want to say it's a digit. It's a thing. It's a bit. It's a bit of information. It can be a digit. Think how long most phone numbers are. 7 plus or minus 2. Not by chance. So, and we know children have smaller capacity. But in general, 7 plus or minus 2. George Miller. If we want to get more information into our working memory, we can chunk those bits of information and make the bits bigger, and so we can make room for more bits. In class, I usually use an example of putting 7 different items on the desk in the classroom. And I use up the whole desk space, and I say, now how can I get more information on my desk? And of course, and you know this, in real life, you do this all the time. You start making piles of materials, and you tend to put together piles of material that are similar. What you are doing is called chunking. I know this is like, it sounds silly, chunking. It is the term we use in cognitive science. You're chunking bits of information together that are similar, and you're making bigger bits. So if you think about a phone number, and we can go all the way up to 10 bits if you consider the area code, we've taken a phone number, and by chunking, we can make it fit 7 plus or minus 2. We chunk the area code by putting a parentheses around it. Then we have the prefix. Here at Miami Middletown, it's 513. And then the preface is 727. And so now we've taken 6 digits and made them into 2. Pretty efficient. And then we have 4 digits left over. That's only 6 digits, easy for anybody to remember. We started off actually with 10, and we're down to 6. And those few people that you may call a lot on campus, you'll actually start making that, putting all of those bits together, and you may have a 3-digit area code, a 3-digit preference, and a prefix, and a 4-digit number. 3 bits. And then pretty soon it all becomes 1 bit because you've dialed that number so much, it's 1 bit. So now that this information is in your working memory, what happens? And I'm going to suggest that under certain conditions, if you are active in processing that information in a way that is especially meaningful, is a good way, or some other way like rehearsal, it might go to long-term memory, or it will go to long-term memory. And if it doesn't, it's forgotten. If it doesn't, it's forgotten. So as you think about things, your job as a learner and your job as a teacher will be to help your students think about information in their working memory in a way that makes it meaningful and in a way that helps them store it in long-term memory so that they can retrieve it. All right. Going back to the characteristics of memory, of working memory, this is an early research study. I wanted to include this. I always include this. It's results by Peterson and Peterson in 1959. And this is information about the length of time information is stored in working memory. I'm hoping with this visual, you'll remember it, because the answer will be on a quiz item. How Peterson and Peterson's research suggested that information stays in working memory without rehearsal less than 20 seconds. Can you see that at 1 second, 88% of the information is retained, but which means that about 12% is lost. At about 10 seconds, you're down to 22% of the information, and so forth. So by 20 seconds, you've lost a significant amounts of information. If you don't retain it and actively work on it, it's like information on your computer screen that will fade away unless you're doing something with it. And I'm hoping this slide will help you remember this information. And then the other thing I said, I did talk about working memory and what is that, and what does this look like? And I'm going to thank a friend of mine that created this or gave me these few slides here. The artwork's nice. I'm going to use it. I really appreciate his work on that. And if you look at this diagram, we have an executive, kind of what they call central executive. Yeah, there's a little character in our head doing this. Not really, of course not. But it's like that. It's somewhere we are thinking about what is this information and what do I need to do with it. Some of the information is verbal. It's going to go over here, or if it's visual, it's going to be processed over here. So let's take a look at that. Auditory information, if it's words or anything to do with words, it's like our inner ear or our inner voice is processed here. And if we're looking at visual information, if I say to you how many windows are at the front of your house, then you're kind of visualizing that and doing some manipulations with that image. That's on this side. And so you can see that, by the way, that I need to back up here, that if we do both visual and auditory, we've got both sides working, which may be helpful. As long as they don't conflict, they may be helpful. And this little character, the central executive, again, I know it sounds kind of silly to use that word, but it's how these areas of memory are being coordinated so that we can have them work together so that as they're going to be transferred over to long-term memory, we now have something meaningful. It's called here a unitary multidimensional representation. It means that we've taken any images or any sounds and we've now made a memory coding that is going to be meaningful, because that's how information is stored in long-term memory. It's stored in a meaningful way. The code is meaning. The code is semantic. Semantic means meaning. So that's how information is stored in long-term memory. It's not stored as an image. It's not stored as a sound or a sense. It is stored meaningfully. I can't tell you what that looks like. I can't draw it for you. But indeed, the code is meaningfulness. I leave you with thinking about how to maximize the limiting characteristics of short-term memory. 7 plus or minus 2 bits of information, 20 seconds duration. How can we as teachers work with those limitations to develop a learning environment and instruction that can help students learn?